Hey guys, welcome to another night of algebra. We're in chapter 3. Welcome. We've made it through two chapters already. Okay, we're going to just review really quickly before we dive in. Go ahead and make sure you have a sheet of paper out as well as your note-taking guide for 3-1. On your sheet of paper, I'd like you to draw a number line, kind of like the one I've got right here. So you're going to draw a number line on your paper, and you're going to number it to 4 up here, and the negative side you're going to label down to -4. Once you have that, I'd like you to graph these points: 4, -3, 9/3, 0, and 1.5. Pause me while you graph those and unpause me when you're ready to check. All right, welcome back. Hopefully you have these points graphed. Let's review. This point 4 is right here on the positive 4 on my number line. -3 is all the way down here on my number line. And let's look at this fraction, 9/3. It is improper. I have to simplify. So 9 divided by 3 is 3. So I graphed that right here. Good job. With me so far, 0 is right here. It's neither positive nor negative. And 1.5 is halfway in between 1 and 2, because 1.5 is the same as 1.5. All right, hopefully you had these graphed and you did these well. If you didn't, I'd like for you to send me a quick text, just so I know that we need to go over this tomorrow. The next thing I'm going to do is I want you to review some of your inequality signs. So when we use equals, that's this sign right here. I know that 4 is equal to 2 times 2, or 2 plus 2. All right, but what if I have signs like this? Remember that if I'm reading it this direction, that which side is my bigger number going to go on? My bigger number goes on this side, the right side, and my smaller number comes on this side. Why? Because if this is an alligator, and my alligator is hungry, it wants to eat my bigger number. My bigger number is my 10. So 10 needs to go on the side of the opening. All right, so remember that I'm going to end up reading this sign this direction because I read left to right. And if I'm reading it this way, it's less than. So if I say 3 is less than 10, it's 3 less than 10. All right, so what about this sign then? Most of you guys get these confused. Well, if I think about this as a dinosaur mouth again, and I don't draw well at all. Ferocious dinosaur. Ears. Okay, so my bigger number is going to go on the side that he wants to eat. It's over here. Smaller number's back behind. I'm not interested in it because I want the bigger number. All right, so again, I read left to right. When I read, I said she walks. I'm reading this direction. I read she before I read walks. So just like I read left to right, I'm going to read math symbols left to right. So let's see what this one means. Okay, I'm reading it this way. So this would be more than. I'm going to put my 10 is more than 3. 10 is more than 3. Or greater than might be the other way I read this. Okay. Now let's looking at reviewing these. I'd like you to write these on your own paper. And I'd like you in the box to fill in one of these signs: greater than, less than, or equals to. All right, pause me and we'll see how you did. All right, here I have two numbers. I want to know which one's bigger. So I'm going to think about this in terms of my number line, because -3 and -5, this is a little counterintuitive. Looking at my number line, which one is most to my right? This one. This is my biggest number. -3 is bigger than -5. -5 is further down this direction. It's technically smaller. Okay, let's practice this with a couple more. All right, go ahead and look at these other 4 for me. I'd like you on your own papers to write down your signs. Is it going to be less than, equal to, or greater than for each one of these 4 problems? Pause me and unpause me when you're ready to check. All right, hopefully you got these answers. If you did, you can skip forward to where the screen goes blank and we start getting into the lesson. If not, let's stick with me while I explain these. Let's break these down. All right, -1 minus 2. This is the same as -1 plus a -2, which should be equal to -3. And over here, I've got 6 plus a -9, which, remember, when I'm adding opposite signs means I subtract and take the sign of my biggest. So also -3. Over here, I have the same thing in my ones column, so I want to look down here. Would I rather have 8/10 of a cake, or would I rather have only a little less than 3/10 of a cake? I want 8/10, so 4.8 is bigger. All right, let's look over here. What happens when I multiply a negative by a negative? I get a positive. So this is the same as +3 times 4, which happens to equal 12. Remember that when you add a negative times a negative, that you end up with a positive. All right, down here, 1/3 plus 1/3 is 2/3, and 1/2 plus 1/2 is 5/2 pie, and I have another half of a pie. I now have a whole pie. All right, just looking at this, hopefully you got the point. All right, if you have questions on these, you need to send me a text, because if we need to review this, then we need to go back here before you can even move forward. Otherwise, we're going to keep moving. Let's go on to identifying solutions of inequalities. All right, let's look at this inequality right here. I've got x something 3. All right, remember that we're going to read this from left to right. So it's x is less than 3, right? Because my teeth are here. So this is it's opening towards my bigger number. So if I'm coming at it from left to right, x is less than 3. Okay, I'm going to give you some new terms now. All right, let's look at this term. The solution of an inequality. You've only seen inequalities that don't have x's before. The solution of an inequality is any number that makes the inequality true. Okay, so let's break this down and let's see what this means. What values of x could make this true? Well, for example, could x equal 5? No, because 5 is not equal to 3. I'm sorry, 5 is not less than 3. 5 is greater than 3. Okay, well, let's look at up here. Let's see about x equaling 0. If x is 0, then is it true that x is less than 3? Why, yes, it is. That could work. What about if I have x equaling 3.001? It's just barely over 3. Is 3.001 less than 3? No. An easier way to think about this might be to look at it on a number line. Okay? If I have my number line, 1, 2, 3, x has to be less than 3. So it's got to be anything smaller than 3. Could x equal 3? Well, let's think about this for a second. Could x equal 3? Is 3 less than 3? No. No, that can't happen. X cannot equal 3. Okay, so if I want to indicate that x cannot equal 3, then I'm going to end up putting an open circle around this, because I'm saying x can equal anything up to 3, anything below 3 this direction, because it's less than. If I had x is less than or equal to 3, then on my number line, 1, 2, 3, 1, 2, 3, -3, -2, -1, 0, 1, 2, 3. Here on my number line, I'm saying that x could equal 3. Remember that less than or equal to? So it could be less than 3, or it could equal 3. If it could equal 3, I'm going to end up filling in my dot on my number line to indicate that it could equal 3. But I also have to keep my line going. Make sure to put an arrow because it's continuing infinitely. It's any numbers less than 3. Or, in this case, also equal to. All right, let's look at another example here. All right, let's look at this one over here. X is less than or equal to 7. I'd like you to do the same thing I did before. I'd like you to draw a number line for me on your paper, and I'd like you also to have a yellow highlighter, and I would like you to map out on your number line, go ahead and label it, and then I'd like you to see, could x equal 9? Could x equal -1? Could x equal 14 divided by 2? Pause me, and I'll check it when you're ready. All right, using your yellow highlighter or a yellowed colored pencil or marker, hopefully you drew this out. You put a closed dot filled in right above 7 because it is equal to 7. And x is also less than, so my x is going to go this direction. Remember that when I read these, I read from left to right, so I read x is less than 7. And how do I remember if it's less than? Because my alligator wants to eat my bigger number. So 7's bigger, so x has to be smaller than 7 for it to still be alive. Okay, so if x is less than 7, the arrow's going this way on my grid, and because it's equals to, my yellow dot is completely filled in on 7. So now let's look at this. Can x equal 9? Well, 9 ends up being up here. Is that part of my yellow? No. 9 is bigger than 7. X cannot be 9. Could x be -1? -1 is right here. Is it in my yellow? Why, yes it is. Is it true -1 is less than or equal to 7? Yes it is. Could x be 14/2? Well, what's 14/2? Oh, that equals 7. Is it true that 7 is less than or equal to 7? Yes, 7 equals 7. So this could be true too. All right, hopefully you got those answers right. Let's do one more, and then we're going to be on your note-taking guide. All right, let's look at this one. We're in your note-taking guide on page 45. We're looking at example 1. Hopefully you already have the vocabulary answer down. Let's look at identifying solutions. I have this problem. All right, let's look at this problem. It's on your note-taking guide in the middle of page 45. Let's see how you would read this. 3 plus 2x is less than 8. All right, your book has you plugging in -2 for x and is asking, could -2 possibly be a solution for this inequality? Could it make this inequality still be true? So I'm going to plug -2 in for x. The first thing you always do is to rewrite your formula or your equation, or in this case, an inequality. And then we're going to end up plugging -2 in for x. Make sure that you use parentheses to protect your item that you're putting in. Let's put this guy in red. And I get 3 plus 2 times -2. And I'm trying to ask, is this less than 8? Well, what is 2 times -2? Remember, you have to do multiplication first. So this is going to become 3 plus what? 3 plus -4. And 3 plus -4? Well, now we need to see 3 minus 4. Remember that you're subtracting here. It's the same as saying 4 minus 3 and taking the sign of the bigger one. You're adding opposite signs. So my 4 is negative, so my answer should be negative. So I get -1 is less than 8. Make sure you're highlighting your negatives in red just to help you identify them. All right, now let's make sure we put this on a number line just to double check ourselves. So if I'm writing my number line, make sure you're doing this on your own paper too, underneath the problem in your note-taking guide. All right. Let's see, where's 8? Oh, 8's up here. Notice that it's less than. It's not equals to. So because it's only less than, I'm not going to fill in this circle. I'm going to leave it open because it's everything right up to 8, but it does not include 8. 8 is not less than 8. But -1 is. Notice -1 falls in the middle of my yellow area. So this is perfectly well done. Good job. All right, let's look at the other one that your book has. We're going to do it in the exact same way. Oh, looking back at this, -2 is a solution because it makes my inequality true. Bingo. Now let's look at the next one. Letter B. Letter B, we have 3, and your book is asking us, could 3 still make my inequality true? Is it a solution? So if I plug 3 in for my x, let's use blue. Could 3 equal x and keep my equation true? Well, notice that you have to end up doing your multiplication first, 3 plus 6, and I want to know if 3 plus 6 is less than 8. 3 plus 6 is 9. Most of you are going to look at this pretty instantly and go, well, 9's not less than 8, but let's just graph it so you can see what this looks like. Remember that on our graph, I want to end up putting a circle around 8. I don't want to fill 8 in because it's not equals to. It is less than 8. And anything less than is going to be anything going to the left on my graph. So is 9 to the left on my graph? No, it's just to the right. So 9 is not less than 8. What this means is that not 9. It means that 3 is not a solution because 3 is the number I plugged in for x. So 3 cannot be a solution for this inequality. Okay. Let's go to the check understanding at the bottom of page 45. Hopefully your answer looks like x is greater than or equal to negative 4.1, so therefore 8 is greater than or equal to negative 4.1. And if I map it out, negative 4.1 starts down here but goes all the way up to infinity this direction. 8 falls in the middle of my yellow, so yes, it is very much true that 8 is a solution. Looking at that, would 0 be a solution? Is 0 greater than or equal to negative 4.1? Where is 0 on my line? 0 is right here. Is 0 greater than negative 4.1? Yes. So 0 is also a solution. The cool thing with inequalities is you have many, many, many solutions that could work here.